good hearing those
getting,
words.
it's feeling real. Is it?
And you know
It
what,
feeling
guys?
real here? Like it's.
I'm looking out and around my windows right now, and I'm seeing a lot more blue sky. I do have to say.
I like to hear that. I like to hear that.
There we
Yeah,
go.
that's that set of clouds off to the west there. You can just see them just dissipate away.
Yeah, baby.
That's what we
Let's
like to
go.
see. That's what we like to see.
All right, so we got some positive trends here for a launch. So once again, we are T-minus 2 hours, 27 minutes, and 15 seconds out from the opening of the window for Starship Flight 12. Starship Flight 12 is the first launch
So I'm trying to fix the resolution on this. So I think NSF just cut their feet as they're transitioning to their other team. So I have to wait a little bit. So this is going to be SpaceX's feed. I'm going to transition to that once they start broadcasting. That looks like it might be better. So, there we go. It's like my internet connection might be kind of hosed. Uh,
we are in.
I don't think they're going to survive. I really don't. Yeah, they're not going to survive. Yeah, it looks like it's going to launch. They're earlier. They're at 55% probability of launch. So I think it's probably gone up.
But they really are dissipating as we just about tick past 2 hours, 40 seconds short of that. Hopefully the sun out here keeps burning off these clouds. I'm okay with it launching. We get some good context right now with the clouds in the background and the rocket. You can see how fast it's actually going. I don't know. What do y'all think?
I think it's very positive, Das. I think, compared to what the weather was when we started today this morning, I think it's quite better. Of course, in certain directions, it's a little bit
Yeah,
iffy. You can see
it's going
here,
to launch.
it's a
Let's turn this
bit
camera around. I don't like
cloudy.
this camera.
Right, exactly. But it's
But it is looking like the weather is improving. That's what we saw in the forecast. We had that rain, those big storm systems coming through this morning. We're still at risk for some pop-up storms. There's an awful lot of energy inland still, but those are almost impossible to predict. You just got to sort of look right when it's time to launch and see if one of those has popped up too close. But I do like the way that the weather is trending here. This is making me much happier and much more excited to go out there and get some more of our cameras up here on the roof in just a bit. So moving right along, do we have any questions that have come into chat? If we could get the panel up, we can actually address a couple of those questions. Again, if you've got us over in chat, tag us at NASA Spaceflight and let us know what you're thinking. And if you're down here, if you're out here somewhere at South Padre Island, interestingly, I do see quite a bit of cars over at Isla Blanca. I don't see a long line trying to get in right now. So crossing under 2 hours from launch, and maybe people are just coming out here right before lunch, but a lot of times as we get closer, we see this long line of traffic trying to get in there. I'm just not seeing that right now, so that's particularly good. But let us know in chat if you're out this way and you're trying to watch from somewhere around here. And if you are out on South Padre or elsewhere, please, please, please make sure you try to stay in the shade, cover up, drink you some water. I need to do that too because I'm going to be talking a lot. And stay healthy so that we can watch the launch of Starship. Now, hopefully, less than 2 hours away if the weather permits, cooperates. I don't know. What do we want to call that? Cooperates.
Goes nicely. I will say though, we have got a couple questions coming in chat. Das,
I think this is the first. Of course, you're very busy. That's an understatement. I think this is the first stream you've been on since Artemis 2, and on all of the streams we've been doing since then, everyone's been asking, what are your predictions? How do you think Flight 12 is going to go? And we've all answered it, but I don't think you've actually answered it. So I'm going to ask you, how do you think this flight is going to go? You're in the hot seat.
Well, I'm in the hot seat because I'm on the roof of the hotel.
On the
Pretty
hot
warm
roof.
up there. I'm on the hot roof right now. You know something? It's almost like Flight 1 all over again. It's a new vehicle. It's a new pad. Both the booster and Starship have significant changes / upgrades. Just systems that have not flown before. We know they have an awful lot of experience running the Raptor engines. We watch McGregor live, and we see how often they test those engines. They got the Cybertrucks pulling engines back and forth constantly every day, and we see how much they test those engines. So I think from a Raptor perspective, they've been able to do a lot of testing with those. Here integrated on the rocket, that's a different story, but that's why they put them together and fly it. The rest of the systems, you reach a point where you just have to send it. You can't sit there and simulate it forever. And we all know that SpaceX is more on the side of hardware rich, flight data rich, right? They'll launch over and over and over again. They're not trying to fly around the moon on the first time like Artemis 1 did. They're trying to get this iterative information. So my hope, and I have no guarantees, is that we get off.
Oh, I wanted to
I think we may have just lost Das there momentarily. Maybe.
see if I can.
Das, we lost you for a moment there, literally
Trying to
just
figure
before
out
you
how to
said,
mute
I hope we see.
the NSF feed.
But you're back
We'll
with
see.
us now.
So,
You
like
can't. I hope
said,
we see.
muted it.
What's going to happen
So-
with the flight is, and then the camera cuts. Sorry about that. It's tough up here on the roof. So
The SpaceX
I-
sniper.
I'm hoping that we get away from the pad, that performance data, all the experience they have running the Raptor 3 is put it on a stool with concrete underneath it.
Yeah.
Here, you see a launch structure that looks a lot more like the NASA launch structures that NASA has been launching from forever. The dual exit flame trenches, the
Or
deluge
Falcon
system.
itself.
Yeah, the massive amounts of water that go onto the pad. I think that more traditional design is designed that way for a reason. It's better for launching the rocket. We will see how it goes today. If they have any problems with the GSE, I imagine it's going to be around the deluge and the water system.
Okay, I'll do it this way. SpaceX put this documentary out. It's about 25 minutes. I might skip a few parts of it, but it's really good. It's trying to just goes over the Starship program, and it covers from the very beginning with. I don't know. I'll let you watch it, but it's pretty amazing. It's from the very beginning. Right now, this is the 12th uh, test flight, and the previous 11 before it. But this is the third iteration of Starship. So this is a brand new. This is the first time this Starship has ever flown. It's a brand new ship. It's a brand new booster, brand new engines, and a brand new launch infrastructure. New launch tower, a new flame diverter, launch pad, all the ground support equipment, tank farm, everything is all brand new. So this is kind of a first flight for this system. This is the largest machine to ever achieve human flight, should it get off the ground today. Starship version 2 held the record before this, but largest flying machine ever made. So that's incredibly impressive right now. It's about almost 3 times the power that was produced by the Saturn V with the Apollo missions. So this thing is just massive. It's got 33 Raptor 3 engines on the first stage, and there's 6 on the second stage. 3 sea level, which are just the same as the ones on the booster, as well as 3 vacuum optimized engines for use while on orbit. So I'm going to play this documentary for a little bit and let you guys check it out. I think it's awesome. We got a little time here. So definitely, if you have any questions, leave them in the chat and I'll try to address them. It's a very well done documentary. Now, keep in mind, the very
Until
first
about
Starships were
4
built
minutes, a lot of
in
stuff
tents,
starts going down.
outdoors. They were welding in the salty sea air right on the
3
beach.
minutes, closing out the propellant load, so you're finishing
so
out the liquid oxygen load and the liquid fuel load.
I don't think it has sound. Here, I'll turn on the sound.
T-minus 40 seconds, we stop interacting with the pad. The vehicle's just on its own.
All right, attention all B-19 operators. This is the final go no go poll for today's operations. Our main objective today is a 10-engine static fire.
Why 10 engines instead of all 33? This is the first V3 booster down at the pad right now, so there's a lot of stuff that can go wrong. It limits the scope of the issues that we can have.
This will be the highest chamber pressure we've ever seen on a vehicle at SpaceX, so definitely going to be a pretty spicy test today.
And then you're counting down from T-minus 40. T-minus 4 on is when my heart rate really starts to tick up. And then we light the engines.
We are in the Star Factory, and this is an almost 1 million square foot facility that we've built to enable that production of both ship and booster. Starship is a fully reusable rocket. It's 2 stages, so it has a ship, which is the upper stage, and a booster below it. The booster accelerates the ship to get it going towards orbit. The ship is what actually goes into orbit to take the people or the payload to wherever they're going. The sound of progress. The rivet guns and the sledgehammers. Less sledgehammers than there used to be. The story of Starship starts with the founding of SpaceX.
3, 2, 1.
Rather than starting with the vehicle that Elon envisioned needing to get people to the moon and Mars, he thought it would basically bankrupt the company. It wouldn't be possible. So you have to bite it off in small pieces. And so those pieces, which at the time did not seem small at all, were Falcon 1, Falcon 9, Dragon, both cargo and crew, Falcon Heavy.
Falcon Heavy is supersonic.
These were the building blocks that let us cut our teeth on learning how to do rockets. Not the way the aerospace industry had been doing it, but the way we needed to do it to end up here where we are today working on Starship. Version 3 is what I like to call the foundational design of Starship booster and the pad. That's going to give us the new capabilities we need to do the missions in front of us. It'll be the one that puts humans back on the moon. It'll be the ones that put the first blueprints and then city on Mars. Starship is giant, and that scale is not an accident. It's not to win some Guinness World Record prize, which we did for both the ship and the tower. It's because we need that size to do the things we dream of doing with it.
Ship 39 is the first V3 rocket. This rocket is unlike anything anybody's ever done before. Version 3 is basically a clean sheet design of the ship. We essentially took a bunch of lessons from version 1 and version 2, and we took a step back and said, what were the things that were really problematic, either from a performance perspective or from a reliability perspective on the previous rockets? And then we directly addressed those with a variety of new designs. It can go up to orbit, it can stay on orbit for 48 hours, it can meet up with other ships, and it can do propellant transfers, which is really the core technology that you need to unlock Starship. Once you unlock that capability, the whole solar system is on your doorstep. And right now what we're doing is we're actually going through checkouts, so we're actually kind of bringing the rocket to life.
We've never built a ship V3 before and gotten it to this state of production. So we are going to have special things to this specific vehicle that are going to be odd, but there's also things about the architecture as a whole that we don't really know how to deal with because we've only done simulations, we've only built fluid models, how we think a ship V3 operates. Now we have the real deal next to us.
First priority is your safety, the second priority is make sure the vehicle's okay, and then we worry about executing to our schedule.
We're quite excited, we're quite anxious, but all things considered, we're pretty well prepared. We think that we'll have a good result.
That's the payload bay door where satellites would be dispensed out of.
We intentionally started Starship with the ship portion because it was so novel. We have done a reusable booster before with Falcon 9, and so it's at least a little bit better tread ground. I will say, I think the booster turned out to be a lot harder than we gave it credit for.
That's a V2 booster right there. It's got 4 grid fins instead of 3. They really decided that they really didn't need a grid fin.
This is an entirely new rocket. This is the most ambitious vehicle design I have ever personally worked on, and it is a wild thing to see come to reality here.
It's a V3 booster. It's got an integrated high staging ring.
The version 1 flight test campaign really exemplifies the rapid integrated test style that we do in SpaceX engineering. It took us 5 flights from our first attempt, from flight 1 to flight 5, to successfully catch a booster, which was honestly mind-blowing. Flight 1 was able to get off the pad successfully. It proved that we could get this full system together, and we learned a lot from the eventual failure of the vehicle in that flight. We were able to put together a lot of improvements on the launch pad and on the vehicle hardware design that led to much better success in Flight 2. We were able to make it with the booster.
On that V1 booster, they really, the launch pad, they didn't want to have a water deluge system at all. They're like, hey, let's see if we can launch a rocket without water deluge. Because when they get to Mars, eventually it's going to have to launch off of Mars, and they probably won't, building a water deluge system on Mars is going to be difficult. So they really wanted to see if they could do that. As you can see with that integrated flight test 1, where they had no water deluge, those 33, I think it was 31 Raptor 1 engines just tore that launch pad apart. Just it was like a blowtorch just blasting a hole through the concrete, through the fondag, through all the steel reinforced concrete. Just blasted a hole. Chunks of concrete went flying everywhere. Some hit the ship as it was ascending. NASA Spaceflight, that YouTube channel, they had vehicles parked with cameras in them. Those vehicles were destroyed by chunks of concrete. A lot of the ground service equipment was destroyed by chunks of concrete. It was the destruction was pretty intense. It was amazing. Yeah, it's they learned a lot from that, and then they realized, well, I guess we do need a water deluge system. So they then came up with what they called the upside down bidet, which was the or upside down shower head, or the rocket bidet, which was basically it's a shower head that sprayed water up into the engine bay, and it worked very well. It protected everything. It did what they wanted it to do. Ultimately, they decided that we're going to just go with a more traditional channel, NASA Spaceflight. They are just regular channel, NASA Spaceflight. They are just regular YouTubers who, once SpaceX started exploding and taking off and becoming good at what they do, their channel took off. And now they have a huge company. I don't say huge company, but they have a large company, a lot of staff, millions of dollars of camera equipment, all this stuff. They have multiple live streamer equipment, all this stuff. They have multiple live streams, 24/7 live streams going at McGregor, Texas, at Boca Chica in Florida, and several sites, as well as and then they do coverage out of Vandenberg, California too. They have employees in Europe and throughout. So they are run totally off YouTube revenue and off of donations. So I'm hoping that you subscribe to them, support them. They're absolutely the best at what they do, and they're not affiliated with NASA at all, despite their name. So anyway, I'm going to continue on with this, and let me know what you think in the comments.
To MECO, we were able to separate the ship, and we were able to begin boosting back towards the launch site. So we hit the next big milestone in the flight test campaign. On flight 3, we were able to get all the way through our boost back burn. On flight 4, we were able to do a successful water landing demonstration. And on flight 5, we were able to come back to our launch site and successfully catch the vehicle with our chopsticks.
If you're not familiar with the reference there, they call these the chopsticks, based on the movie Karate Kid, where Mr. Miyagi catches a fly with chopsticks. So another nickname they have for this launch tower is Mechazilla. So it's like Godzilla, but mechatronic. So yeah, so they're catching a fly with chopsticks, just like Mr. Miyagi. That's why they call these the chopsticks. But as you can see, this booster came back to the launch site, and these robot arms came back and caught the booster as it returned to Earth.
To be able to go fly that and have complete mission success at that point of we got the payload to orbit and we landed that rocket was incredible. I'm getting goosebumps talking about it now.
And they did it on their first try.
about to get into a really exciting period of the vehicle test campaign here, putting the thing through its paces and making sure that everything we design works okay.
Right here?
To get all of the pieces of the system working together for the first time, and if we're going to learn anything from that, we'll learn it as quickly as we possibly can. Booster 19 is actually the second of the version 3 boosters that we've built. Booster 18 came before it. We had an unfortunate anomaly during our first test campaign of the Booster 18 vehicle. This is the first version 3 booster that we built, so this is Booster 18. This is really awesome because it's going to be our first full vehicle level operation and test with a version 3 vehicle, so the whole team's very excited about this. Sure hope it works.
This is tragic.
When we were pressing the nitrogen system, we had an explosion that took out the rocket, and thankfully we had designed that test to be safe. If something like that happened, we did not have propellants or reactive things on the vehicle, and so the test site incurred very little damage, and of course nobody was hurt in the incident.
Yeah, as part of testing, this is loud, so you learn to not be super skittish as you're walking around. So we have our booster here on site. We're going to be performing a cryo proof. It's actually a really long day, so it's nominally planned to be a 12-hour overall prop load and offload. It's just a ton of propellant that we're putting on the vehicle, and we do a bunch of test cases throughout the whole day, so it's a long one.
Taking booster SM to cryo high fill proof.
Cryoproof is the first time you actually put propellant onto the vehicle. The liquid propellant that we're putting on, it does get pretty cold, generally in the 80 Kelvin range. We want to test like you fly and fly like you test.
Now on 70% proof percentage. Stay firm. And fuel interface is fully cryo now.
There is definitely nothing like a late night with your team in the control room. It's one of those milestones where you're like, wow, if I can load a rocket, this is amazing.
The FHT looks pretty stable. Let's go ahead and get booster configured for offload. Copy.
McGregor, Texas is their engine test site. This is where they bring all the engines, whether for Falcon 9 or Starship. They bring them here and they test them on the ground. They have horizontal test stands as well as vertical test stands. That right there is Grasshopper. This was before the Falcon 9. This was this was a test vehicle, which is basically just one large tank with a few Merlin engines at the bottom, which they use to learn how to land a booster. So I highly recommend going out and watching the test flights for Grasshopper. because they're really cool. They did them right here in McGregor. And you see the cows and stuff running around the field, kind of wondering what the heck that thing is going on. But there were a few malfunctions where they had to self-destruct the thing in flight, but ultimately they did successfully land the Grasshopper, and they used the information that they learned from that campaign to successfully transfer into the Falcon 9 program. So they learned how to land orbital boosters, and they've done over 600 successful landings to this date.
This is a Raptor 3. V3 is a high-performance boost engine. It's also designed to be reusable and highly reliable. We've learned a lot over the course of producing around 600 V2 engines. You can see the amount of simplification that's occurred between V2 and V3.
I mean, look at this kid. Oh my God. Like this young kid with the dreadlocks. Where is he? With the dreadlocks.
The course of producing around 600 V2.
He doesn't even look 30 years old. And he is the vice president of fucking Raptor engines. The most powerful, the most technologically advanced rocket engine ever built. The only full flow staged combustion engine to ever successfully fly. The Russians tried this and they could not make it work. And, you know, this team here with the Raptors, this is the third iteration of the engine. And when you look at this engine, it doesn't look like it's even complete. It's like, where are all the parts? Where's all the tubing? Where's all the things? And even Tori Bruno, the CEO of ULA, when SpaceX posted a photo of this engine and said, hey, look at our Raptor 3, you know, it's really super simple and low mass and all this stuff. Tori Bruno replied on Twitter and said, hey, well, you know, that's cool and everything, but it's not really fair that you didn't even post the completed engine. It's still missing all these parts. And Glenn Shotwell, the COO of SpaceX, then posted an image of the engine on the test stand firing at full thrust. So, well, for an incomplete engine, it works pretty damn good, you know, something like that. But look at this. I mean, these are the people building stuff. It's like the Apollo age, because you think about Apollo, and everyone thinks, you know, those were kids that built that. Apollo was run by 30-year-olds, 25-year-olds, 20-year-olds. It wasn't run by 50 and 60 and 70-year-olds. NASA today is run by 50, 60, 70-year-olds. This is the same kind of energy that put humans on the moon for the first time. It was the kids who didn't understand that there are rules. And you have NASA filled with all these bureaucrats and 50, 60, 70-year-olds who said, well, you can't do that. It's too risky. It's dangerous. It's whatever. It's not going to work. And this is the kind of energy that brings innovation to this industry.
You can see the amount of simplification that's occurred between V2 and V3. The level of integration is really unique for Rocket Engine. That comes from a lot of work among many engineers to consolidate the hardware. The effect of that is that it's actually a higher reliability design. So fewer parts is cheaper, faster to build. So that allows us to make a lighter vehicle, to make a more reliable vehicle, to overall just build a better rocket. Achieving full reusability of an engine like this is really something that people haven't done before. The goal is to get the engine to behave in a similar way to the engines on commercial airplanes. Frequently in interactions with people outside of SpaceX, the perception is that things far beyond what have ever been done before are impossible. Things being impossible is really to be determined by breaking laws of physics. We are not.
That right there is a huge thing, because SpaceX operates on the idea that there are no fucking rules whatsoever. The only rules that exist at all are the laws of physics. If it violates the laws of physics, well, yeah, you can't do that. Other than that, there are no rules. And that's huge because no one else thinks that way.
Breaking laws of physics, we're just trying to leverage them as effectively as we can.
All right, attention all B-19 operators. This is the final go, no-go poll for today's operations. Our main objective today is a 10-engine static fire.
Static fire is the culmination of the engineering process. We're bringing all of the pieces of the puzzle together and we're lighting the engines. And if you make it through that, you have pretty good confidence that you're in a good position to go fly.
Aboard. On LVN1, looks like we kicked out 2 combustors from the apex bank being faulted.
Looks like we have to engine time of 2.135 seconds.
We successfully lit all 10 engines. They were ramping up to power. Everything was looking good, stage and engines combined. However, there was a pad side abort called. So what that means is some sort of sensor tripped, and from there we command a fast shutdown.
It was a hard one, and especially since we had to drop all the engines afterwards, and thankfully 10 of them were salvageable, which is good.
We saw some data right after static fire that showed about half the engines had what looked like mechanical damage, basically as a result of the really fast shutdown. So we brought the booster back to Mega Bay. We then decided to remove all 10 engines from the booster so that we could troubleshoot and understand what's going on those 10 while still making progress on B-19 by backfilling engines from B-20.
All right, attention all operators on LVN1. Today's main objective is a 33-engine static fire on B-19. Okay, go, no-go poll coming up in 1 minute.
So we're doing our static fire today with all 33 engines.
This is the final go, no-go poll for today's operations. Flight software?
Go.
AY?
Go.
Raptor?
Go.
Stage?
Go.
CE?
Go.
GC2?
Go.
GC1?
Go.
FC1?
Go.
Two has 10, 9, 8, 7, 6, 5, 4, 3, 2, mission.
Wow.
We kicked out early. All teams triage alerts, prepare for offload.
Today we aborted our second attempt of the B-19 full count static fire. We actually had another pad abort on the diverter. We made it through engine startup and then ultimately lost some of our sensors on one of the ramp manifolds. It basically said that the manifold pressure was lower than we believe that it probably was, and it kicked us out at T plus 1.88 seconds. It's just tough because there are some things that are hard to test ahead of time. So the diverter, you can test as much as you want, but you can't obviously test for what theoretical vibe and environment you're gonna see when the engines are turned on.
Anytime that you walk into an operation where you want to turn on 33 of these enormously powerful engines and get them all to work together and walk away from it in one piece, that is a win.
I think every test is always a success, and we had a bunch of findings on the ground systems, the vehicle, and the engines that I think were really good to flag at this point, but definitely a bittersweet day.
We have a saying called "only the paranoid survive." The idea behind it is that there's an enormous amount of information and data that's coming to you, and if you can use that wisely, you can actually use that to figure out where things are going to go wrong in the future. And almost every time that we fail something or have something go awry, there were clues in previous data and previous operations that if you had known what to look for and had been good enough and paranoid enough to do so, could have found it there.
It's been 10 months since Massey's had the S-36 anomaly.
Ship 36 was a tough one. We had a CPV explode, and it not only took out the rocket, but it took out a lot of the test site infrastructure over at Massey's.
How do we go make sure if we have an anomaly again, the pad can take a beating and still survive?
Losing a rocket is one thing. We've got a production line for rockets, and we can go make more. Losing the physical infrastructure of the launch pad or the test site is very difficult because you need to go repair that over a period of many months before you can get back into testing. Now we have Massey's back online here. We've really, built this rocket from scratch, but we've also built the pad from scratch, so it's all kinds of new systems. This will be the first time that we bring together the pad and vehicle pieces to make sure that they all work.
Static fire vehicle is in pre-pad clear, about to get to our static fire pad cleared op state.
We run 60 seconds on ship because you get to see how the vehicle thermals all shake out and just general vehicle performance.
That if you can make it through that you are in a reasonable position to go fly.
Start up. Throttle up. Plus 10.
The journey of SpaceX is a journey to give humans access to the solar system and beyond, which is really the goal for Starship.
Plus 20.
The impact that this rocket is going to have on the world.
I don't know if you go back and listen to that. Give access to the solar system and beyond. So SpaceX has in their mission statement, not only to bring humans to Mars, not only to bring humans to other parts of the solar system, but beyond the solar system to other star systems, to planets orbiting other stars, which can be light years away. I think the closest one is probably 4 or 5 light years away, which at current levels of propulsion would take thousands of years to get there. They have, many companies have a 1-year plan, a 5-year plan. Toyota shocked U.S. car manufacturers because Toyota had a 100-year plan. And when they tried to meet with U.S. automakers, the U.S. automakers laughed at that. That's stupid. It's like, we're not going to be alive around then. Who cares? At which point the Japanese put an end to the meeting and said these people are retarded and they don't deserve our time. SpaceX has beyond a 100-year plan. They have beyond a 1,000-year plan. They have a 10,000-year plan. And that is huge. And no one else is doing that.
I don't think most people can really comprehend the change that's going to happen.
This is such a wild ride. The highs are high and the lows are low as we really work to get to ultimately launching people, which is going to be amazing.
Plus 40.
It is not impossible just because it's far beyond what has been done before. We've proved that time and time again.
Plus 50. Full duration.
So that was that. I just wanted to show you that because it's huge. That kind of lets you know a lot about what's going on with Starship, with this Starship program. If you're new to this, this originally started as a plan to make humanity multiplanetary, so that we have more than one planet to live on, just in case something goes wrong with one of these planets, such as I don't know. Well, basically, the idea is to have a backup planet. If we could be on more than one planet, and something happens to one of those two planets, well, humanity survives.
Because we've seen them testing that
And
over.
there have been many, at least 5 or 6.
That might be the one sort of risk
extinction events,
today.
mass
But
extinction events.
my prediction,
that
I
have
think it's
killed
gonna,
all
if the weather
all life,
cooperates, that's
not
gonna
just human life,
I think we're
but
going to
all
get
life
off the
on
pad.
Earth.
I think we're going to get out over the Gulf. It's going to be a final time.
The
We're
laws
gonna
of
see what
probability
happens,
state
but
it's going to
you know,
happen
SpaceX,
again.
They want to get the flight data. We all hope, we all require
So if we're on more than one planet,
that it's done safely
we'll
when we
survive
get the
that
flight
event.
data.
If
But
we're not,
SpaceX
we
is not
will
afraid
not.
to send that
We
vehicle
will
out there and make sure that
become
they get
extinct.
some. It's not really ground
So
truth; it's flight truth. Right?
the mission of
That's how
SpaceX
they do
is to
their
prevent human
engineering.
extinction by
So to summarize
being
your answer, Das,
not just
it
on
is
Earth,
not
but
going to
on
do
other
occur.
planets, not just Mars,
I
but
didn't say
other
that.
planets as
It
well,
would be exciting if it did
and
occur.
even other star systems. That is just
We will
absolutely
see. I do
huge.
think that they have, from
So
a control
so
systems
anyway,
perspective.
I'm gonna bring it
I'm really
back
putting a
to
lot of faith
the
in those Raptor engines because we've
NASA
seen
space
how much
flight
testing they do at McGregor. You don't
coverage
see any
of the
other rocket
event.
program that
Their
tests the
commentary is
engines the
far
way
better
that
than
they test those
mine.
engines at
These
McGregor.
people are
So
experts,
I think if today
and
goes well, you got a lot of credit to
once
give back to those folks at McGregor who
SpaceX
are making sure that
starts
these engines are healthy and ready for flight.
broadcasting their feed, which will be 45
I'm
minutes
going to see if
before
we've
T
got some more
minus 0.
questions coming into chat
I'm
to ask,
gonna
because
switch to them,
we've got a lot of people joining us in chat.
and then I'll
whilst
offer
we
my
have some time to
commentary as
fill,
well
whilst we
on that.
still wait. Ethan is one asking if it's true that cameras on the Starlink mass simulators are to inspect the heat shield. If so, how are they be able to in an hour's time?
Oh, it's all good. It's formative. It's like how we make ourselves who we are. It'll be very interesting to see how that goes. But we'll get you like a recovery video or something. We'll take some pictures and show it to the members what that thing looks like after we get to it.
100%.
Let me say real quick. We'll get you a couple more in a second. But every time people show up and they support us like this, you've heard the phrase like vote with your pocketbook or vote with your dollars. When people do a tip like that, or they do a super chat, or they buy merch or whatever, it's like you're voting your confidence in us, because we turn that around. None of us are running around in Ferraris or anything like that. I have a 2014 Toyota Camry if you're interested, but we're turning that money back around and we're using it to support college students who spend their time writing our articles and stuff like that for us. We're using it to support Ryan here, who's editing videos and doing your Starship updates and stuff like that. Max, the photographer out at the Cape, who's capturing everything for you. We turn it around to new equipment, cameras and stuff like that. None of us are getting rich from this because we are doing this because we love it. We're space nerds that reach critical mass. We had a specific set of skills, a lot of different skills. We came together and we wanted more excuses to watch rocket launches. That's literally why I'm doing this. I love watching rocket launches, and I just needed an excuse to watch more of them. And that excuse is helping share it with you so that more people can see and be involved in this sort of stuff. So
if you ever get a chance to watch a rocket launch, do it.
Thank you all.
You don't
for
need an
showing up
excuse, just
and
do it.
supporting what we do. You're absolutely awesome for being a part of the community and helping us keep this
The
going.
videos,
Space
the
nerds
photos do not do
You're
them
supporting
justice.
folks who love doing
Being
this.
there
and
and
give
seeing
us a
it
tip.
for yourself
You're
and
voting. You're
feeling the
saying, hey,
rumble
we trust that y'all are going to
Feeling
turn this
the-
around to some crazy
feeling
new
the earth
shot,
shake.
or I don't know, a solar panel that doesn't exist anymore, but the camera was
There's nothing
absolutely
like it.
fantastic. Whatever it is, we do appreciate y'all showing up every single time. Thank you so much.
I could not have said it any better.
Do we have a couple more to hit, Ryan? Again, we don't want to make the entire show about it, but we want to say thanks.
Yeah, absolutely. We've got
I've
one
never
more big
seen
one
a
here
rocket
from Joe
launch
with another 50
like
gifted
this.
team
No one,
memberships. I mean,
very
there
few
have been
people
so
have.
many
I've
gifted
seen
memberships, so many
Falcon
super
9
chats,
launch
so many store message. I'm going
and
to do Control F to find store
Delta
message
4
in our
Heavy
panel, and I can tell
launched.
you there are 134 store messages and counting in this panel. So
I can imagine what it's like to watch one of these things go
Godspeed
off.
to the
It's
person
gotta
at
be
the end of the stream who
incredible.
has to read those
Even
out.
if you're 5-6 miles away,
Wait, isn't that you?
you will
I thought that was
feel
you.
it in your chest. It will shake
find
the
out.
earth.
We'll find out.
It'll be you.
It's incredible.
We're gonna like
Gets
rock
nervous.
paper scissors at the end of the stream to see who has to say thanks
And
to the
then
entire team.
there's also the visual element.
All right. So let me check the clock.
When you watch
Coming
it,
up
you know,
on
you
an
see the
hour.
engine
It's
go
an
off,
hour
but
and
it
7
is
minutes
extremely
right now.
bright. It's
If
like
you're just joining us, you found NASASpaceflight.com.
the engine bay is
over on
like
YouTube.
a little tiny
Bringing you live
sun
coverage. We're not
at the
sponsored
bottom
by
of the rocket,
SpaceX.
pushing
We're
that
not
thing forward.
paid for by a big media corporation. We love doing this, and we're able to do it because y'all keep showing up.
You know,
So if
you look at the
want to get
video
back
and it looks
here,
kind of a
you know what to
yellowish,
do. Like click the
orange
little
color.
bell or
No, that
whatever
is
it is on
bright
YouTube
white.
these days. Like and subscribe. It's not compulsory, but if you like hanging out with us, we'd appreciate having you back in the future. Let me look across the way. I do see some more clouds over on the Mexico side. That's going to be sort of like to the southwest. They're pushing out further over the Gulf, so we're getting more blue skies over to the left from my perspective, and a little bit of clouds forming over here as we're approaching the T-minus 60-minute mark. Again, it's not every single cloud.
Starbase
That's a
Texas,
problem for launch. It's
which
different
is near
types of
Boca
clouds.
Chica,
Does that cloud
is
potentially
right
contain
on
a
the Mexican
thunderstorm?
border.
Does that cloud have the
Like
ability to
literally,
connect you to another
if you
cloud
walk
that has a
across this launch
thunderstorm?
site, you're
There's
in
all
Mexico.
sorts of different
It
requirements.
is
So just
touching
because
the
there's a
Mexican
little
border.
cloud doesn't mean it's the end of the world. Right now, we do still have pretty
They wanted to
clear
get this thing as
skies,
far south as
especially
possible
out in
because
the direction that the rocket
the
is
closer
supposed
you are
to
to
be
the
going.
equator,
So we'll continue to watch the clock as we count
the
down
less
towards
fuel you need
Starship's Flight 12,
to
going through all
get
the
yourself
different
into
beautiful
orbit.
camera views here on the screen.
And that's because of the
Who wants
rotation of the
next,
Earth.
Ryan or
The closer you are
Alex?
to
Any updates we
the
need to jump in
equator,
on? Because
you know,
y'all know I talk
at
a
the
lot.
equator, your
I
angular
will say
velocity is
there
at
is
its
another
maximum.
aircraft that has been
So
spotted coming into
roughly
the area.
1,000 miles
Unfortunately,
per
I don't have to tell
hour
you what
at
the
the
aircraft is,
equator.
but it's very interesting
Of
because it is
free
one which has the FAA
velocity you
information
get
obscura
by
thing
launching at
applied
the
to it.
equator.
So we
That
genuinely have
means
no idea
to get
what
to
that
orbital
aircraft could
velocity,
be.
you don't need to
But I
spend as
can
much
tell you it's
fuel.
approaching Brownsville. So if we do get
So that's why they
information,
launch from
I will let you
Florida,
know. But maybe that could be more
Texas,
VIPs
Southern
coming up.
California.
They have. I will quickly look back at the track
The
and see
closer
where
you
they've
are to
come
the
from.
equator,
I think they've
the
come
less
from
fuel you need.
Florida area. Maybe I should have zoomed out before I started scrolling back. There we go. They come from Miami, so maybe we'll have to see what that is.
I guess we'll have to see what that is. Alex, I am going to say that you are remarkably quiet. Normally, Alex has all these updates flying back and forth and, oh, this pipe and this bit and that sort of stuff. Are things just sort of ticking along?
Well, the only update that I have in terms of tank farm activity is just that the tower vent has stopped as part of the normal behavior that we see. It seems like at least for pad 2 it will be very similar than for pad 1, where the tower vent starts, then it's sort of venting for, I don't know, like 20-30 minutes or so, then it dies down and it disappears for a little while, and then it comes back again once closer to propellant load, and it sort of comes back really stronger. It's sort of like the tower has its own sort of plume, sort of cape behind it, and things like that. Sort of really epic kind of thing, especially with a full stack on the pad. And when that happens, usually it means we are close to that propellant load sequence. The vent then disappears, and that's your indication that they're starting liquid oxygen load on the ship. Because okay, so we have breaking news.
Alex is very excited about this breaking news, y'all.
Yeah,
Stand by. We're going to get y'all some more
I
information.
just saw it in front of me. So it appears we have at least a 30-minute delay for the moment. on the T0 for today's launch. You might see now the top left corner, that clock has changed, and we are now 93 minutes away from liftoff. And SpaceX confirming on X that they are targeting now 6 p.m. Central for liftoff of Starship. So we have official confirmation that we are indeed 30 minutes into this 90-minute window. So only a third of the way in. So, you know, it's
Okay.
not a great deal. It's just a third of the way in. It's okay. It's much better than in some of the previous flights. But look at that. I think is that the tower event coming back again? As I was saying, it might do.
That's a beautiful shot.
Whatever. Anyways.
Oh, whatever, says Alex. That's where we are at the count.
Sometimes
Alex
it does
saying
that
whatever.
kind of thing. Sometimes they like to tease us, but it's not coming back to the delay. It's not a surprise that we got this update now, because at T-minus 50 minutes is that go no go poll sequence to basically the flight director polls the operators to proceed to whether proceed with the propellant load sequence or not. If they already know that they are not ready to go, that there are some things that need to be dealt with, they of course will not go straight into that poll and just move that T0. So it's not surprising that we got this delay about 10, 15 minutes away from when that was supposed to happen if they had gone at the opening of the window. Now, 30 minutes into the window, so we'll have to wait another 30 minutes to find out what happens.
Good deal. And an important thing here, there are different types of rocket launches that go to different destinations, right? If you're trying to rendezvous with the International Space Station, you have a very tight window. Some rockets have a few minutes. Some rockets, we call an instantaneous window, which means if you're going to meet the International Space Station at a specific spot in space at a specific time, you have to launch at a very specific time, right? Here with the Starship test flights, they're not trying to rendezvous with the ISS or anything like that, right? So you have a little bit more leeway. It's more about hitting the hole that has been cleared for you. Things in orbit, you're not wanting to pass other satellites across their trajectories. In the sky, where we've cleared out the planes and boats and stuff like that. We don't clear boats from the skies usually, but you have a little bit more leeway in the window, and that's where this hour-and-a-half window comes in, because we're not.
We saw in Artemis 2, they had a 2-hour window. It's even longer than this window today, because it's an hour and a half. So it all depends as well on the performance of the rocket, where you need to go. Usually when you have to rendezvous with another vehicle, as you said, that is when you have your tighter constraints, the most sort of tightening constraints in your launch window and things like that. Certain rockets might have a few advantages, like spare performance, in order to you can sort of zigzag your way into orbit, basically, and you might have a bit of a maybe 10 minutes, even if you were to be going with a rendezvous in orbit and things like that. But again, we're not in that situation, as you mentioned. This is a test flight. They're making sure that this baseline version 3 can do the minimum requirement, which is copy what has already been done. Let's make sure that everything is good to go. And from here, we'll build up and do all of the other things, like going into orbit, extended stays in orbit, get another ship to dock with another ship, transfer propellant, get an HLS, all of the other things, many different things that they need to do in order to get through Artemis, their own Starlink constellation, DTC, etc., all the different things that they want to do.
Interestingly, as we get into some of the HLS, if you've heard about the Starship ships that are going to rendezvous with each other, and you have like a tanker starship that fuels up another starship. When you start getting into those rendezvous, even if Starship is not going to the International Space Station, that's where we might start to see some of these launch windows tighten up a little bit. Starship's first rendezvous will be with things like that. And we also have Alex HLS coming up, where we've heard rumors about HLS providers, of which Starship is certainly one, rendezvousing with Orion and testing out docking and approach and that sort of stuff to support the Artemis program returning to the moon, right?
Indeed, they added that extra mission. So basically, Artemis 3 turned from a lunar landing mission in 2028. Now it is a rendezvous mission in 2027. So it was pulled forward in order to fly faster that SLS rocket, be able to gather more experience with it, because it's a bit of a pad queen, as they call it in the industry.
Pad queen.
In that sense. Yeah, it likes to S-word, to abort on the pad and do all sorts of things, leaks of hydrogen, helium valve stacked stock and things like that. So yeah, they want to fly it more often, better, get a better handle on it. And so one way to do that is to reduce risk on your landers, because why would you go straight away with a landing? And like it doesn't make sense, right? Apollo did this with Apollo 9, where they did a low Earth orbit test of the lander, and then Apollo 10 did sort of a simulation of the actual landing without landing. Of course, the landers will do that on their own without any crew, because it's not the 60s anymore. You don't need any pilots sort of with a stick and whatnot to pilot these things. That to the surface. So that is one of the things that they're going to be testing after Artemis 3. Okay. Boy. So speaking of crew, let's revisit a little bit of a certain set of questions that we sent our crew ahead of Flight 11. It's been a while. It's been 7 months. Let's see who actually talks about that sort of thing. Starship's last flight happened in October. Yes. In October. And it was also the last flight of version 2, a version that gave us lots of headaches when it comes to, well, doing what Starship needs to do in order to achieve its goals in the future. It was also the last flight out of Pad 1, which gave us lots of different memories, very fun moments as well. And we gave our team a series of questions about what they hoped or expected for Flight 11, and also what they expected for the future of Starship.
What do I think will be the outcome of Flight 11?
Honestly, great success. I think Booster 15-2 is going to do everything that it is supposed to, and accurately.
I think it's going to be a good outcome. I really, really want to see that this is a repeatability of Flight 10. It's one thing if you do it once. It's another thing if you can repeat it over and over again.
They learned a lot from the last flight. They're doing basically the same profile. Yes, there's a few changes, but I think that this is going to be a great success.
Now, a lot of people in our team were very hopeful for Flight 11, and they were sort of right. It was a success. But there was something.
I think version 3 will go through some headaches like version 2 did, but I'm really hoping with all of the component testing that we've been seeing happening so far, that it goes a little bit, at least, smoother. I mean, as long as they don't blow up another ship at Massey's, it'll be fine, right? Right?
Yeah, so there was a question about whether version 3 will give us any headaches, just like we got with version 2, and let's say that a lot of people did not pass that test, including myself. We also asked our team, what was the thing that they were most excited about for version 3?
The thing I'm most excited about the next version of Starship is that it's going to launch from Pad 2 and be a much more efficient launch mount that hopefully gets to be reused more rapidly.
100% the brand new version of Super Heavy. While technically we are currently on the Block 2 or Generation 2, as some SpaceX engineers have officially called it. It looks very, very similar to what we began with in Booster 4 and then Booster 7.
What excites me about the next version of Starship is seeing the Raptor 3s in action.
I'm really looking forward to how the infrastructure holds up. They've learned so much from the current Pad 1, the OLM, the Deluge.
And I think we're going to get more pretty photographs and video from a launch mount with a big flame diverter like that.
No, Jack, we will not have pretty photographs from you because you went asteroid mining. Thanks, Astroforge. But the prediction that everybody got wrong, really wrong, was when version 3 will debut.
I think we are going to see the first launch of version 3 probably in late winter, early springtime. So probably end of February, early March, probably at the earliest.
Well,
in March of 2026, maybe right around my birthday?
I think the first launch of version 3 will be February 12th at about 9:30 p.m.
I'm going to go with March 16th, but please keep in mind I'm now 11 for 11 on guessing wrong on the actual launch date.
I'm calling it right now. So I was hoping that Flight 12 would be around the holidays. You know, I'm sitting there baking cookies while I'm watching the live stream. Everyone's in their cute NSF holiday sweaters, right? But since we are still waiting on the new launch pad to be finished, I just have this feeling in my bones that Flight 12 is going to happen at the worst possible time in February.
I'd be absolutely shocked if we see them pull off the first launch of version 3 before the end of the year.
I'm gonna guess probably around the springtime frame. The pad will probably be ready way before the vehicles. I'm just excited to see a full stack on the redesigned Pad 2.
Right now, I think it's going to be spring, and I'm going to say 2026 because, this could be clipped and be like, oh yeah, you were right, and it's like spring of 2027. Hopefully that doesn't happen. That being said, there were two people that were actually right. It was me. I was right. Spring 2026. Also Gage. Gage also said that. Hi Gage. Now here in SF we had a very diverse set of answers, as you can see, but there was one answer where we all agreed upon. And it was the answer to the following question that I'm going to make you, the viewer. Are you excited for today's launch? I know I am.
Outstanding. A little blast from the past there with some of the folks that we see in the video. But we are now back. We are going to do a little bit of a crew rotation, just like we do in space on the International Space Station. We also rotate our crew. I've got some work that I need to go do to prepare some of our robotic tracking assets here on the roof of the Margaritaville at South Padre. But joining me is going to be Mr. Sawyer Rosenstein. Sawyer, how you doing?
I'm doing great, Dos. It's good to hear you back on the stream again, and good to be with everyone for a Starship launch again. It's been a while.
It's been a while. I said who's going to be joining me. You're very briefly going to be joining me because you're actually going to be replacing me. You're going to be taking my place, right?
Wait, you mean I'm going to have to go out to Starbase now? I'm in Florida. It's a little far away, but...
We need you here in 15 minutes. I'm done.
All right. I'll go steal a Concorde. Sounds good.
Point to point. The problem is it has to start from here and come pick you up and then come back. I don't think we're quite there yet.
Darn. All right.
All right, folks, you've seen Sawyer on all of our videos. You see Sawyer on our live stream. I will let Sawyer take it from here. Again, if you're doing questions, tag us in chat. The super chats, the tips coming in and the merch and stuff that you're buying across the board, all the different ways that you're supporting us. Sawyer will be helping out. Continue to say thank you for that. But for now, I'm John Galloway. I'm going to go get some more cameras set up so we have more views for you from over here at South Padre Island. And I will see you nerds later.
Thank you, Das, and thank you, chat, for joining us here for the Starship Flight 12 launch. I am Sawyer Rosenstein, as Das mentioned, and I'll be with you here for a little bit as we continue to count down to launch. Again, hopefully launching in about an hour and 20 minutes from now. If you're just joining, we did have a 30-minute delay, so it may seem like we're not going that far, but hey, look at this. We are progressing a bit. You can see there is one of the roadblocks, and the vehicles are moving away. So Alex, what does that mean?
That is great news. That means that the blast danger area is being cleared and that everybody is out of that danger area, because we don't want them in that blast danger area when launch happens. As we were talking about that before, remember that we were saying that it's right on the edge, but it's still within the circle, right? It's like the difference between just staying a little bit inside. That curve is done. That's basically the end of the blast danger area. It's not really that far out. So they moved up, and that is great news, because it means we're progressing towards that propellant load sequence, hopefully in about 40 minutes from now.
That is what we are hoping. As you mentioned, at about the 15-minute mark is when they do that poll to verify that they are go for propellant load. And again, all of that assuming that they continue with the countdown, which so far they are now counting down to 6 p.m. Central Time for launch. Man, that is a beautiful view. I have a feeling once we get to tanking, my heart rate is really going to start pumping. Chat, I'm guessing you're going to be the same way there with the excitement here.
Your heart is going to start pumping, but
faster.
What about the pumps? They're going to be pumping as well.
Oh yes, exactly. We are going to hopefully see them pumping in the methane and the oxygen into this vehicle that you see here on your screen. And what still boggles my mind with Starship, especially with V3, is that the load time for this entire massive vehicle, the largest vehicle ever launched into space, is almost the exact same amount of time as a Falcon 9 vehicle, which is only 3 meters in diameter, and there is basically a transfer tube in the booster that is about the size of a Falcon 9 in it. And it only takes that short amount of time. That still is mind-boggling to me in a good way.
I thought that was a great pun, and Soy didn't even congratulate me.
He just turned it into a segue.
Of course. I try and use segues as much as I use puns. I guess I have to be on my best behavior for a stream like this today. Oh, man. Also, it was really cool to see some of the past NSF people on stream. I mean, to see Jack in there from his Flight 11 video. So many people that we've had here at NSF, if you watch past broadcasts, going, where are they? They've kind of moved on, but they're doing great things. I mean, we have, what is it? We've had 5 people now who have taken the NSF pipeline to now work at SpaceX, including many of them that are in Starbase for this particular launch today. It's really cool to see.
Yeah, probably more than 5 by now, to be fair. I think I lost count already.
I think it's 5 since I've been working here at least. Possibly more, yes. But and we continue to see there that vent coming from the tower. We also saw that tank farm still kind of venty. Is there anything, Alex, that we're looking for in particular coming up now that we're kind of under that hour 20-minute mark?
We're mostly, so from a visual standpoint, the only thing remaining will be that tower vent, because it seems like it's actually doing what we saw yesterday on the wet dress rehearsal, where it sort of started, then died down, and then it started again, and then it died out. It was a mess. I have a spreadsheet here with what happened yesterday, and it's a mess of tower vent starts, tower vent disappears, tower vent starts, tower vent disappears, and multiple different times written down and everything. It's bonkers what they did yesterday with that tower vent. But it seems like right now they're doing pretty much the same, because it died down before a couple of minutes ago as we were playing that video, and then it went up again, which is quite funny, to be honest. But yeah, it could be doing the same sort of behavior today as well, where it sort of starts, disappears, starts, disappears. It's a bit of a cuckoo game, I guess, or something like that. I don't know. But yeah, it's basically just watching Advent, of course, watching for updates from SpaceX. We had that 30-minute delay being called at T-minus 1 hour and 5 minutes or so when we were tracking a liftoff at 5:30 p.m. Now we're tracking 6 p.m. So potentially in about 11 minutes from now, we may see another update from SpaceX. We'll see whether that actually occurs or not. If we don't get an update, I will venture to say that maybe if it happens to be that they actually go through and they decide to go to the poll, to that go, no go poll at T-minus 50 minutes, then that is when we might get the next official update. But as we always say, we'll just keep waiting and see what happens.
Exactly. I mean, we joke about the Texas Tank Watchers, where we would just sit and watch tanks for hours and hours. If you've been joining us, including during the stakeout stream, that's kind of what we've been doing today. But this is when things finally start to pick up and get really exciting now. The final 75 minutes, hopefully, at this point here. Also, I love the view on the bottom, as Das has been talking about, trying to protect all of our cameras and gear with that protective plating in front of that wide-angle lens. And then, of course, we have those super close-up shots like the ones you see in the top left and top middle that are probably a little bit on the dangerous close side, but that's why we're nicknaming it Danger Lot and our Danger Trailer over by Danger Hopper? I don't know. Maybe a little too far on that one. Oh, man. Now, chat, I've been seeing you guys with all of the hype in here, even with everything still going on with the delays. There's a lot of hype in chat. Ryan, is there any questions from chat?
We have questions. You can rest assured, we have questions. We have so many questions coming in. If you do have questions, do tag us at NASA Spaceflight or at NSF. First of all, Resistojet is asking, why have they put black squares on the underside of the ship? Alex, I'm going to assume they're asking about the new patches of heat shields that have been, well, I say patches, large splodges of heat shield that have been added to the shiny side of Starship.
Yeah, based on the material that they have used to apply those tiles, it seems like they're trying to test some kind of new glue. We talked about this before, where the great majority of the tiles on Starship, about I will venture to say maybe 90% of all the tiles on Starship, maybe even more than 90% in fact, are pinned. So there are pins welded to the body of the ship, and then there's like a sort of a triangular sort of backing that is on each tile that holds the mechanical connections to those pins on the vehicle. However, there's a minority of these tiles that are in very hard to sort of place areas for these pin tiles. Like it's maybe on the tip of the nose cone, for example, the flap edges and things like that. So those are, instead of pinned, they are glued to the vehicle. And believe it or not, that is also the same way that the shuttle tiles were installed. They were actually installed with glue. And one of the things that they struggled with in the space shuttle program was with those tiles actually sticking to the vehicle, because that glue used to fail every now and then. I mean, for the most part, most of the tiles will stick on and will stay on, but then it was a challenge to actually maintain and refurbish that sort of thing. So it's no surprise that for Starship, SpaceX has lost tiles on Starships before, and the majority of them has been on the areas where they are glued, basically, where they are actually with that glue. So they're seemingly testing a new kind of glue in these leeward tiles, and we don't know what sort of composition, but they do look different because it's like purple glue of sorts, whereas the other one that we see it's usually red colored instead. So that is basically the long answer to all of this. Trying to explain a little bit the differences here. Might be people out there that might not be aware of how the Starship heat shield works.
Yeah, again, it's always always joking about shuttle-derived problems, and it's very similar to the shuttle era, but it is a different material. The shuttle ones were silica-based. This is something called tough rock, and yeah, I guess using what we learned from the past and improving it for the future, and maybe, just maybe, we get a chance to actually see some of the tiles if we get one of those Starlink deploys with a camera on it. We'll get back to that in a moment. Ryan, I think you have more questions.
Yep, one more for the time being. Colonel Bologna, great at there, asking, will the rocket go straight up off the pad, or will it immediately turn east to mitigate damage to the pad like previous launches? Alex, of course, from pad 1, they had that avoidance maneuver. Starship kind of tilted towards the Gulf as it ascended from pad 1 and roasted the booster quick disconnect in the process. Are we expecting something like that again on pad 2? Of course, it's a slightly different rotation orientation this time.
Well, I would expect a very similar thing to what we saw on the first pad. The big difference now is that that's basically where you don't have the booster quick disconnects, so they're not going to be roasted this time around. I don't see any other kind of difference there. I mean, my background picture sort of can show you already where you have the Starship and then the booster quick disconnects are sort of around here if we were to clear the there we go. So the booster quick disconnects are in this area. East is sort of this way in this direction to the right of the flame trench, and so it's gonna go that way. And ironically, when it goes that way, it means that then the plume is facing the other way, right? Because it's sort of sloped in an inclination sort of thing, and so the plume will be facing this way, and it'll roast this area of the pad very similarly to what we saw on pad 1, just opposite. Basically, it's like 90 degrees. It used to be sort of this area, now it'll be this area instead, because it's going to head this sort of way. And so that is basically what we might expect from this launch if they do the same pad avoidance maneuver that they did for pad 1. If they were to do that, then this sort of area will be the one roasted, but there's no critical infrastructure anywhere here. There's no booster quick disconnects, there's nothing, and this blade that they have around the launch mount that will be shooting up water that will be helpful for covering all of that energy and you know, temperatures and pressures and everything that will be exerted from the 33 Raptor 3 engines that are on the base of that rocket. Trying to adjust here.
There we go. Of course, as Ryan mentioned, you can tag us at NSF or at NASA Spaceflight for those questions. We try to answer as many as we can, and they don't just all have to come from Super Chats like you may have heard us talking about before. And we are doing all of this with our own cameras that you see on the screen right now, all of our own people. We have a lot of people out there in Starbase, all of our teams that have been working behind the scenes to bring all this to you. And if you can't even support us financially, a simple way to do this is literally just click the like button on the bottom of the stream. And if you like what we do, we're a bunch of space geeks and we cover this stuff all of the time. So there's also that subscribe button next to it if you're interested in following more cool things happening in spaceflight, especially with Starship itself. So we appreciate you guys watching as well. Now, one thing I mentioned before in terms of watching was going to be hopefully getting to see some of Starship itself with the Starlink payloads. And again, it's interesting the wording that they changed now. It's not necessarily Starlink simulators, but in the paperwork that they've applied for, it does say Starlink satellites. So they might be operational satellites. Of course, this is not going into orbit. This is still a suborbital trajectory. But we're talking the possibility of seeing actual Starlink satellites for V3 deploying the flat pack type, and maybe seeing one or two of them with a camera on board. Because I know that's something that we've been talking about here, is hopefully, if all goes well, maybe SpaceX will show us a view of the outside of the ship from one of those Starlink satellites. The caveat, of course, being that will kind of be on the dark portion of its trajectory. But, I mean, Alex, that wording is really suggesting that these aren't just the quote-unquote dumb links or mass simulators that we've seen of the last couple flights here.
Yeah, because it says including a payload deployment of 20 Starlink simulators, similar in size to next generation Starlink V3 satellites, and 2 specially modified Starlink satellites. And that is interesting because it also doesn't even include what kind of satellites is it? Is it like, can you imagine if it's a V2 mini of sorts, like the ones that are launched by Falcon 9? Those are sort of like half the size of the Starlinks that Starship carries. But you could, in theory, sort of have one that has sort of like extensions that reach out to the pest dispenser of sort, right? We were telling about this sort of as a joke for ride shares for other companies. Instead of having to develop a satellite the size of the Starlink satellites, instead of like they can still be flat packed so they can fit through the pest dispenser. But in theory, you don't need it to be as huge because it's like 7 meters long and 3.5 meters wide. That is huge satellite, right? In theory, as long as you have extensions that reach out to the rails of the pest dispenser, you can have the satellite sort of in the middle. That would be hilarious if there was some kind of next generation pest dispenser that can do that sort of thing. So who knows? Like you could in theory even do that with B2 minis, the ones that are launched on Falcon 9 and have a great production system already for that sort of thing running. Who knows? We don't know because it just only says two specially modified Starlink satellites. We don't know if they are V3 satellites, if they are V2 minis with extensions or whatever. Can you imagine if they are even V1 and those are even smaller satellites? But it will be funny otherwise. It's going to be an interesting thing to find out. And this is why we always enjoy these launches, because you're always learning new things.
You know why we also enjoy them? Well, we enjoy the tank watching part. We don't enjoy announcing this part. SpaceX announcing that there is indeed another delay into the count. So originally they were targeting 6 p.m. Central Time. They have added an additional 30 minutes to that. So they are now targeting 6:30 p.m. Central Time.
Probably because of weather.
So unfortunately, that clock in the top left that has added time to it is in fact now correct. Yeah. I know everyone's getting worried and all the
95 minutes
and issues. We don't know exactly why at this point, just that they're continuing to push it a little bit. But I guess they still have at least 30 more minutes in this window, which is a nice thing to keep in mind. And add in the fact also that not only do you have 30 minutes more in the window, but let's say they were to start the prop load in an hour and 35 minutes from now and they notice something, they can hold a little bit into this count. We don't know exactly how long with V3, but I know for V2, it was about, 15-ish to 20-ish minutes that they could hold with propellant loaded on the vehicle. So
that probably hasn't changed much.
Maybe they just go for the prop load and becomes a WDR anyway, although we don't exactly know, again, why this is, but SpaceX indeed pushing things 30 more minutes. And
so I'm
guessing we haven't seen anything else.
They have a launch window. They're still within the launch window, so they still could launch, but they had to delay another half hour.
It doesn't say SpaceX. I don't see any sort of indication
they could do
of what exactly
another 30-minute delay and still be able to launch today, but after that they'll have to scrub.
Has improved way
and try again tomorrow.
It's dramatically better than earlier in the window.
But
I mean,
it says if it doesn't launch today, they'll consider this a WDR, which is a wet dress rehearsal. So the practice going through the countdown.
This is one of the things that it's usually. It would be great if we got a bit more information.
It's training, it's learning opportunities.
That it's holding them. It appears as if they
are able to recover most of that fuel that they onboarded onto the ship.
Venting going
they
on
just
there.
pump it back into the storage tanks.
In a standstill.
There's some boil up, there's some losses.
Whenever they are
but
ready to actually
the vast majority of that fuel and oxidizer will be recovered.
Kick off the next step in this final portion.
The costs are not too great
ahead of that propellant load. Again, it's something that we really don't know. SpaceX has just now confirmed on X that new T0 of 6:30 p.m. Central, but with no sort of note of what exactly is that it's delayed.
All right, so 6:30 p.m. Central, that's 4:30 p.m. Pacific, which is where I'm at.
So if they need those 30 minutes and
7:30 p.m. Eastern time,
they'll probably take it. So
let's hope it launches today. It's gonna be great.
We were saying this before that it happened.
It's been 7 months since the last one, so really want to see this go.
1 hour and 5 minutes when it was tracking 5:30 p.m. Then when it was tracking 6 p.m., it happened around the same time as well, T-minus 1 hour and 6 minutes, T-minus 1 hour and 5 minutes, more or less. I would expect if there's another delay, we may have to wait until that, now that we are tracking 6:30 p.m. Central.
That is something that we will watch. And you mentioned the weather. Earlier, the weather was looking quite rough with a whole bunch of rain and things if you're watching the stakeout stream. Ryan, weather seems a lot more improved compared to what we had.
The weather, Sawyer, is so much better than it was when we all woke up this morning. This is the radar behind me around the Brownsville area. And as you can see, there is really nothing at all concerning. I mean, we can look further inland. I'm not seeing any rain popping up. We can look out to the Gulf. I'm not seeing any rain popping up. I mean, at least on the radar, things are looking a little bit better, quite significantly better than they were when we began our stakeout coverage 10 hours before the original planned launch time. I'll also bring up our forecast of the dew point and air temperature again. This is kind of indicating where clouds could be. So this is more for visibility than for launch criteria itself. But if we have a look here in the 9-kilometer range, there's a little bit of cloud that could be popping up, and we're seeing that on our cameras of this cloud, you know, a little bit higher up. So shouldn't be impacting initial launch views, but maybe that's something that our team will have to kind of fingers crossed and dodge around when it comes to the launch itself, because Starship, of course, is going to be going a little bit higher in the sky than 9 kilometers. Fingers crossed, we hope, fingers crossed it's more like 150 kilometers and it makes it all the way to the Indian Ocean. So fingers crossed this cloud doesn't get in the way.
Yeah, that's what we're hoping. And we were always talking about with that graphic, oh, don't worry, that's towards the end of the window. That's 90 minutes into the window for that. And yeah, we are now 60 minutes into that 90-minute window. So it's getting closer and closer to those conditions. But at least we have that clear radar compared to this morning when teams were setting up some of those cameras and everything. It looked quite wet and quite miserable. Now, it's interesting with these vents here. I mean, Alex, after the wet dress rehearsal, we saw them going for hours and hours. And then, of course, if you were watching earlier, we saw the tanker trucks lining up pretty much all night, overnight, until just a couple hours ago, loading up that tank farm. Can you kind of walk us through when we talk about the tank farm, what exactly we're looking at and what this venting kind of is?
Yeah, we have this very useful overlay from Ryan Kaling himself, and with the help of Ryan Weber, the two Ryans working together here to bring us this overlay. So let's start, how about all the way to the right? So the methane reclaim vent that we see there being pointed at, that is part of the system that turns the methane from gas to liquid, because you have that boiling off as you flow it through pipes and subcoolers and all the things, and you don't want to vent that because it's a hazardous gas, and so you turn it back into a liquid, and that's the vent. In that case, that's venting nitrogen. It's not venting any methane. It's just part of the system that turns that methane gas into methane liquid. Subcooler vents, similar thing, where you have nitrogen being vented off as they subcool. They densify that propellant from boiling temperature down to about 20 degrees Celsius lower than usual, that boiling temperature basically. Box fan vent, that other vent as well, that is for the chill down of the pumps, chill down of the subcoolers as well. In the case of the subcooler vents, in this case, I believe that's the methane side of things. So it's for the methane subcoolers. The ones for the liquid oxygen subcoolers go to the box fan vent. It's a whole different thing. We will need an entire 1-hour stream for that. We're not for that. We are here for the launch, so I'm running quickly through this. Service structure methane drain and then service structure oxygen drain that you see there in the middle. Those two relate to part of the end of the countdown when everything is loaded on the vehicles and the OLM, the orbital launch mount, has already done its thing. Then the service structure that is next to it, that sort of shield at the base to the of the launch mount, that one gets purged. They drain all of the things in order to be able to save it and basically make it safe. That's the whole word that I used for that, in order to reduce the risk of anything going wrong. And then the tower event, which we've been seeing for the last hour or so, just part of that chill down of the liquid oxygen line that goes up the tower. And so what is venting out of there is oxygen. But that is basically what we're seeing right now. As I said, to explain all of this in more detail, we will need an entire 1 to 2 hour live stream, but we are here for the launch.
Yes, and for those just joining us as we reach right around the top of the hour here, I'm Sawyer Rosenstein with NSF, NASASpaceflight.com, a group of space enthusiasts here with all of our cameras and team set up in the field to bring you views and sounds and everything leading up to Starship's 12th flight and the first of V3. I'm Sawyer Rosenstein with NSF. And at this point, you may be looking at the clock and going, wait a minute, that should be at T-minus 30 minutes for the opening of the window at 5:30. SpaceX has indeed pushed that window by about an hour up to this point. So as of right now, they are targeting launch about an hour and 30 minutes from now. So that is 6:30 p.m. Central Time. And the window does extend until 7 Central Time if they need it. As we were just talking about, we've been seeing that tank farm quite active at this point, but not loading those propellants yet. And that doesn't happen, by the way, until we are about, what is it, about 40-ish minutes until launch is when we start to see those prop loads begin. So we still have plenty of time to get there and plenty of time to answer your questions at NSF at NASA Spaceflight. You can see from the screen the weather looking much better than it was earlier today. And right now, everything proceeding. We don't know why they've pushed an hour into the window. SpaceX hasn't specifically said the reason for that, just that they have indeed been delaying it 30 minutes at a time. A reminder, this is the first flight of version 3. So while it may look very similar to the Starships of the past 11 flights, there is a lot that is different underneath the hood. So there are a lot of inner workings that have changed. We are talking brand new engines as opposed to the Raptor V2s. These are the Raptor V3s. You have a lot new inner plumbing and wiring, the new downcomer inside the booster, different tile setup for some of the parts of the ship. So much has changed that you could almost call this a brand new vehicle in a way. And in fact, it essentially is, hence why they're switching the name to V3. This is also the first time that we will see the brand new launch pad fully used for a liftoff. This is the first time Pad 2 has seen a full stack ready for launch on top of it. All the other ones have been from Pad 1, which is currently undergoing refurbishments. Another new thing for this one is also the trajectory a bit. Things are quite changed from what we've seen. Yeah, I mean, sure, it's still going to be splashing down into the Indian Ocean. The booster will still be splashing down in the Gulf, but there's a bunch of differences to where it's going and also the timing a little bit. Ryan, do you want to kind of walk us through what some of these changes are?
Absolutely. You know, one of the interesting things, I'm actually going to start at the end of the flight. It might sound counterintuitive, but if you give me a minute, this is the air hazard which has been put in place for re-entry of Starship. It'll be coming from, of course, over Africa, heading this way towards the coast of Australia, which you can just about see, just there, creeping into frame. But this big hook here, this is the really interesting thing, because on the last flight of Starship, we saw them doing kind of a banked maneuver with Starship as it tilted towards the splashdown site in the Indian Ocean, and that we believe was actually a simulation of the trajectory they would fly when returning to Starbase for the tower catch. Because of course, if you've seen the animation, SpaceX's animation shows the ship coming in from the north and landing, coming over the tower and landing in the chopsticks in the tower. So they have to do this kind of banked trajectory, as you can see, heading up towards the north, then turning around and coming back down south in order to hit that tower catch. And that's a very interesting thing. This is, of course, a bit more of a different trajectory. It's more than just this hook at the end of the trajectory, because if we move over to Starbase proper, we can see here that there is a brand new flight corridor which heads a bit more southeast than we saw with the previous flight corridor here in white. Before, they'd launch out of Starbase and fly over the Gulf, threading the needle between Florida and Cuba. And now, instead of going between Florida and Cuba, they're going to be going between Mexico and Cuba. So a couple of degrees inclination, a bit more southeast than what we saw on the previous 11 attempts of Starship. One of the reasons for this could be because it's a bit closer to the operational Starlink inclination that they will want to be hitting with Starship. Another possibility is the fact that air traffic between the United States and this area of the Caribbean, notably Puerto Rico, a little bit more busy than the air traffic headed between, let's say, Cuba and Guatemala. So a little bit less air traffic disruption by flying in this corridor than when flying in this corridor. And at the end of the day, when you add all of these things together, you get one more big trajectory. If I can find it, I can't find it. I'll show you that later. But that is the initial air hazard areas, which is the new trajectory that Starship will be flying. I'll show you the full thing later.
We're looking forward to that coming up. There you go. It's a reason to stay tuned, folks. We will have more graphics from Ryan Caton. But yeah, so the timings also, given that this is a lot more powerful engines on these vehicles, might also change a little bit. Some things will happen a little bit quicker than they have in the past. And while we have some time here, again, the tower event stopping and starting in the kind of dying down part at the moment here. Alex, these Raptor V3s, I mean, we talk about the strength of Raptor V2s and how powerful they are, and if you've seen what a Raptor V3 looks like, they look so simplified, and yet they are so powerful. What kind of a difference are we talking about here, Alex, between V2 Raptor engines and V3s, besides a lot more power?
It's almost 10% higher thrust in this case. So we go from 230 metric tons of thrust to 250 metric tons of thrust. So if you're a pound user, now I don't know the one per engine, but I do know that at liftoff, Super Heavy created about 16 million pounds with Raptor 2 engines. Now with Raptor 3 engines, it's actually over 18 million pounds of thrust. So that is a lot of thrust. That will be about 81,000 kilonewtons of thrust. If you use kilonewtons, if you just use tons of thrust or metric tons of thrust, that will be, if I'm not mistaken, 8,250 metric tons
Newtons
of thrust.
and kilonewtons are trash
So I have
units.
to know these numbers off the top
Yes,
of
it's
my
the
head,
SI unit,
otherwise
but
it will be messy having to look these
it
numbers
really is overly
all the time.
complex.
But that's
Should be abandoned.
basically how big these numbers are. It's bonkers. Das talked
And
about
then
this
you got to
at the
convert it
beginning of the
to
stream,
and from.
where like whatever records you might think
Um,
about for a rocket of how big, how
units
powerful,
that are
how
usable.
heavy, all of those go to this rocket because it is the tallest Starship
But
rocket
it
to
makes
ever
sense to
fly
say
of
SI
all of the
unit.
configurations.
But,
It is the heaviest, the most powerful. I mean,
metric tons are
whatever way you
definitely
put it, it's breaking
more
all sorts of
meaningful,
records today if it launches,
even though that's not the
which we want to
standard
launch,
unit.
by the way. I want it to launch.
Well, I mean, it will definitely launch. It's just a matter of when it will launch. So
The reason is,
hopefully,
you know, the
an
mass
hour
of the
and 20
vehicle,
minutes from now, we will
mass of the
see
vehicle is given
those
in tons.
33 Raptor V3s ignite on the booster,
So
and
when
shortly
you
after,
calculate thrust, if
those
you calculate
6
the thrust
Raptors up on the
in
ship,
tons
the
rather than
3
newtons,
Raptor vacuum
then there's
and
no
the 3
conversion
Raptor
needed in order
seawater.
to
Which I saw someone
understand
asking, when are we going to get the
what
6 variant,
your
the 9-engine
thrust to weight ratio
version
is.
of the ship? I think that's still a little ways away. They kind of need to prove that the variant that you see on your screen works, considering this exact configuration has not flown yet before today. Oh boy, it's still exciting. Again, it may not be at the launch exactly yet, and they still have 30 minutes if they need to use it. Let's hope that they don't need to use it. That's what we're really hoping for, and that we see this thing lift off shortly. I know we've been getting a lot of support. I've been seeing all the awesome messages popping up in chat from everyone. It's great to hear from all of you. But we've also been getting some support that I do want to make sure that we thank, because we can only do what we do because of support from you. Ryan, do you mind hitting a couple of those for us and thanking the people?
It's a nice rhyme from you there, Sawyer. First of all, Russell, thank you for gifting 20 Red Team memberships. These aren't all of them. These are just the big ones because, like I said, there are over 135 store messages in this panel right now. So it would take us all the way until launch to read them out. But we will get to them, I do promise. Continuing to scroll down the list here, we got a big tip from Kevin G. A $100 tip at tips.nasaspaceflight.com. Here's a little something. I mean, you're so subtle, Kevin. Here's a little something to keep it going. Seriously, thank you so much. That is bonkers support. Same to Paul with a $50 tip at tips.nasaspaceflight.com. Thank you. Tibbeth with a €100 super chat. I mean, what else? What have we done to deserve this? Thank you so much for your support. They're asking if there are different payload sizes planned for V3 variants, or will those have to be V3? I know the dummy Starlink V2s on this one's 44 tons, but will V3 be able to do more than 100 tons to low Earth orbit? What do you think, Alex? Are they going to be changing the... I assume they're asking about the number of satellites that they'll be loading to be able to actually physically fit compared to the mass.
The ones that can fit in this PES dispenser are about 60 of them at a time. It depends what kind of... I think maybe they were getting confused between Starlink versions and Starship versions. So the Starlink version has changed now from the V2 to the V3. They have iterated. Like originally Starship was supposed to launch Starlink V2, but instead they just kept it to V2 minis on Falcon 9 instead. Yeah, they have iterated already on those, and they have created the Starlink version 3 satellites now. Those are still the same size, but obviously all of the hardware has been changed, and so that's the important thing. We don't know exactly how heavy those are. I wouldn't venture to say whether it's 44 tons. There's multiple different numbers out there. Some people take, for example, the 2 metric ton number from a certain documentation from a Federal Communications Commission permit, where it talks about whether it's like a study about the deorbiting of these satellites, but then it says we're just establishing it that it is 2 metric tons. It might not be 2 metric tons. Then for the old version 2 satellites that are also sort of the same size, Elon said at one point that it was about 1.25 tons basically in mass. So anywhere in between 1.25 and 22 tons, and 2 tons, you get, I think it's like between 30 and 44 metric tons for the full 22 satellites that are riding on this vehicle. And so that is definitely not the limit. They can load, at least from a volume standpoint, up to 60 of those on the PES dispenser. We've seen the stacks and everything on the renders and everything, but also the PES dispensers themselves. You can see them when they roll them out, and you can see the slots and all that. Apart from that, SpaceX has also confirmed already that it's 60 of them. Other sorts of variations of the Starlink satellite, like the direct-to-cell satellites version 3, those might be 50, according to the IPO documentation that was released yesterday. But other than that, it will not hit, I think, the mass limit of Starship. Any more questions?
And we have just one more of the big ones coming in. One Beat Short, thank you for gifting 20 Red Team memberships. And with that, I will hand it back to Sawyer.
Thank you very much, Ryan. Appreciate you checking in on that. Appreciate everyone helping out with the support here as we continue to count down to Starship Flight 12. About an hour, 15 minutes to go. We are getting to within that 5 or 10 minute range of where we saw them push it last time, so hopefully we make it beyond that point. As we mentioned, the big poll that they use for the go for prop load is about the T-minus 50 minute mark, so we still have a little bit of time to do that poll, but the last couple times that they pushed it, they did do it a little bit earlier, prior to that 1 hour mark. So all eyes are going to be peeled on socials, on all of the posts, and of course, what you see here on your screen right now with all the tank farm activity, with all of the vents and the lines and everything that you see on your screen. It is starting to get to feel real at this point. As mentioned, they do still have 30 more minutes in the window if they need it. We are, of course, hoping that they don't need it at this point. So right now, again, it still boggles my mind at how big this vehicle is. I mean, obviously, in the box comparison, I'm not larger than Starship, that's for darn sure. But it is a really tall vehicle. You are fitting a Falcon 9 inside the booster itself. And in terms of diameter, you are talking 3 meters versus 9 meters in diameter. It is a massive difference. So when we talk about this being the world's most powerful rocket, the world's biggest rocket ever launched, it is. And a reminder that V3 is even slightly taller than V2. Anything that we're seeing right now as we continue to look at the tank farm and all of the venting and things from the lines, Alex?
Yeah, it seems like they're just keeping steady that tank farm. The only thing that I noticed was that on the tower, it seems like they further chill down that liquid oxygen line on the quick disconnect arm that goes to the ship. It's a bit more frosty further down the line, if you will. There's like a certain valve that they can actuate and continue the chill down closer to the ship. Instead of just being up to the tower, it sort of continues to the ship. It's very similar, Sawyer. We cover this many times with Falcon 9 when we talk about the T-minus 20-minute vent and we say that chills down the lines that go up to the second stage and things like that. Technically, I believe that one is actually sort of the last mile chill down sort of thing, right? Where it's that connection in between the stromac and the line that actually hits the sort of interface with the second stage of Falcon 9. Very similarly here, it seems like the lines that go to the ship are split between, you know, all of the things that go underground and up the tower, and then you go to the quick disconnect arm, and then there's like a valve that stops that flow. And then you have another stretch of that pipe that goes all the way through the quick disconnect arm out to the ship. And so it seems like it is that little bit of that line that goes up to the ship that is now, at least I see it frosty. I don't know if it might be the illumination or something like that. I do not see the same on the methane side of things. It seems like that is still being held at ambient temperature, but we may see that being kicked in once they are much more ready to go into this propellant load sequence. Again, we are at least 21 minutes away from that go no go pull sequence, and it might be a little bit more until we actually get that propellant load sequence with liquid oxygen load starting on the ship at T-minus 38 minutes and 53 seconds. So still a while.
Still a little while to go, but one thing I've noticed with rocket launches as someone who typically covers them both here online and doing the field coverage for NSF for some of the launches, the final hour goes by so ridiculously fast, it doesn't feel like time is real at that point. When you are in the moment and everything locked in, especially once you get that go for prop load, time just flies. So hopefully we get to that point, and once we do, I promise you, chat, you'll be looking at the clock going, wait a minute, I thought it was just an hour to go. Now it's a half hour to go. Now it's 10 minutes to go. Now they're ready. So hopefully we will see that coming up very soon. Also, I love this view, being able to look up at the Starship ship itself, seeing some of those tile patches there and some of the upgrades there to the V3 ship. This, our team able to deploy a trailer full of cameras to a lot that is, I believe, about under 1,000 feet away from the rocket. So our cameras there, we're calling it Danger Lot now, and our Danger Trailer over there getting really close. So fingers crossed it will actually survive all the way through. But we'll have to see. It's going to be interesting to see how these cameras survive, and also importantly, how the rest of the infrastructure, the trailer itself, the solar panels, everything stays on this.
I don't think any of us can survive.
It'll be exciting, though. Excitement guaranteed, as SpaceX always says in their timelines. And I think the excitement will definitely be guaranteed. There's definitely the excitement as well for everybody out in the field, counting down. I know Isla Blanca Park, there was still some people getting in there about an hour ago. I'm sure it's quite different now. But yeah, that's one of those that fills up really quickly. We also have team members, you may be able to hear some of them over at Rocket Ranch. We are very grateful that they allow us to have a camera there. It is another great spot to see a launch from pretty darn close. And speaking of, apparently, we have a surprise, according to Kevin Michael Reed, the producer. What do we have? Is that Max Evans? Hi, Max.
Good afternoon, everybody, and welcome to the Rocket Ranch Outpost, which is also known as a front row seat to Launch Pad 2, or just Pad 2, I guess, in this case, for Starbase. Still getting acclimated from the Space Coast of Florida. But we are here with a bunch of people who have come out today to watch this first launch attempt for Flight 12 on this, what turned out to be a beautiful afternoon. We were a bit concerned with the weather this morning, but it looks like the forecast has improved greatly since then. Despite the two 30-minute slips into the countdown. We are monitoring that as well as everyone else is. But as far as we can tell here, we have a great view out to the launch pad, and so does everybody else here. I forgot how good of a view this was. Like, that 7 months, I don't know about you, D's behind the camera right now. It is so good to be back right now. Like, it's difficult to overstate. So everybody, enjoy our coverage as best you possibly can. We are bringing you all the views that we possibly can. This is going to be a good one, and hopefully the weather cooperates and the countdown continues as planned towards 6:30 and no more delays. But back to you guys in the studio, and go Starship.
Thank you. Max Evans out at Rocket Ranch. You can see all the people behind him, and with all the excitement behind him, I know the microphone's like, wait, I want to jump into this. So got a little jumpy there, but great to see Max, and excited to see the views that he gets from there. As you can see, it's a pretty clear shot over to the pad from there. It's a good view, and it helps also now having that bi-directional flame diverter. So if you've seen any of the launches in the past from Starship, it becomes very difficult to see the rocket as soon as those engines ignite, because there was no real place for that exhaust to go except up and around the vehicle. Now having the new flame diverter is a huge improvement. In fact, that's one of many improvements to what Elon and SpaceX in the past have called Stage 0. And by that, we mean all of the ground support equipment. If you've been watching any of our coverage the last couple days, which if you're not, I don't know where you've been, or seeing any of the posts on our socials, X, Facebook, Instagram, Threads, TikTok, Blue Sky, you've been seeing all of the deluge tests that they have been doing for the last week or so at this pad. It has been, I think 9 of them or 10 of them in the last week alone. So yeah, they are really making sure that everything is in place to protect the pad and protect the vehicle. And I mean, we've seen a little bit of a difference with the way the water goes. So, but yeah, so it's amazing to see this thing fully stacked here. Of course, we talked about the Stage 0, but we also have Stage 1 and Stage 2, and to see those stacked together is really cool. But of course, you have to stack them. And of course, before you stack them, you have to build them. But the real question is, how do you build a Starship? Well, if you ever wanted to build one of your own, we now have this brand new merch at shop.nasaspaceflight.com. If you've followed our Artemis collection, this may seem a little bit familiar, continuing in the style of how to assemble your own for a certain furniture store from a Scandinavian country that we don't want to necessarily name for copyright infringement. But it's very similar to that, and you even see the little umlauts in the name there. But yeah, that is how to build a Starship with the ship itself, with all the amazing changes that have been made to it for V3. So we talked about all the changes to Stage 0, but you can see some of those stages right there on the shirt. And this is now part of our Flight 12 collection that we have at shop.nasaspaceflight.com. You can see it right there at the top of the page. We have all the different shirts. We've got mugs. There's baby onesies. There's Hawaiian shirts now, which are really cool. And you can see there is that new design included in there. Of course, don't forget, we also have some of these new designs. Yep, like this brand new Hawaiian shirt. I have one of the ones for Dragon, but now we've got a new Starship. Look at that, with the belly flop. I love it, with the flip and burn. So you can flip and burn as you flip some lays on top of your shirt in this Hawaiian shirt. This is such a cool design. I love it. Even the entry heating. And look at that, it's got the flame diverter we were just talking about there. It's got the pad too. That's awesome.
Yeah,
and of course, boy, I hope we get to see that today.
Oh man, I hope we get to see that too. Hopefully it launches, and hopefully we get to that point in flight. And then of course we also have the pins and patches version of it too. Apparently we have less than a quarter of all of our patches left. The supply is down to less than a quarter of them, under 25% remaining, and once they are gone, they are gone. We do not add them back in some special reprint or anything. They're gone. So all of this is shop.nasaspaceflight.com. The shirts are there. People have been asking about the pins. I used to love collecting pins. I need to get back into it, and I got to get my ones for Starship now too. I know Alex has been flexing his mug that he's been drinking hot cocoa out of.
We're not showing it because I actually, there we go. That's the Flight 12 patch on the mug, and also on the shirt as well. So there you go. You can have it on all sorts of different things. I actually still have a little bit of cocoa, but it's no longer hot because it's been a while since I actually served it. So yeah.
So you need new thermal conditioning for your mug at this point now.
I'm sure maybe some of the tumblers that we have in our store might help me in the future. I still do not have any of those yet, but maybe I'll have to acquire one of those.
There you go. That would be cool. Of course, I'm wearing my Flight 12 shirt as well. Super comfy. But yeah, the hot cocoa is dissipating. We don't see any exhaust coming from Alex's cup. We, of course, still see the everything that you see with the frost there on the fuel tanks and all of the farm over there. Of course, you see all the people down there, too. I believe this is the camera that was over at Rocket Ranch. All the people there enjoying some Texas barbecue. Boy, now am I hungry. So thanks for that, Max and D, and for the team over at Rocket Ranch
I was gonna say,
providing that.
now I'm hungry.
Yeah, but we're also hungry for a launch, which hopefully we are about an hour and 2 minutes away from that happening. We've seen them have a couple of pushes so far into the window at this point, but right now they are still proceeding. We have made it further than we have the last 2 times. So it is getting exciting now. Hopefully it stays that way. Hopefully they continue with the countdown. And if so, that would be a liftoff at 6:30 p.m. Central Time, about an hour into the hour-and-a-half long window that we have for today's attempt. Oh man, what a view. This is so cool. Of course, the birds enjoying it. You've got the tank farm going. I know people were talking about the box fans. I know those weren't on the original graphics, Alex, but what were those box fans doing? Because it looked extra kind of venty around part of that tank farm there.
It's just part of the system that they use because back in the day they will just dump it overboard with like different size tubes and things like that. Nowadays, what they do is those tubes, instead of leading to just the ground, they lead to a fan that is literally blowing upwards. And so that means they can blow up all of that venting instead of sort of staying on the ground like a carpet. It goes up and then it floats away. And so that's why nowadays you may see the tank farm and you might think, wow, that's a lot more active than I saw when Pad 1 was going on and things like that. That's because the Pad 1 tank farm used to be, again, this sort of carpet on the ground sort of thing. It was more, how to say this, more lazy, if you will. The vents will just sort of stay there, rest on the ground, and the nitrogen will sort of hang around and everything. That was very iconic, very fun, and very enjoying. For example, when they did the first catch on Flight 5 and the booster came back, the boom of the sonic boom of that vehicle literally blew away all of that carpet of condensation that had remained on the pan after liftoff. It is nice, but it can become hazardous when you have a lot of nitrogen concentrations. It is true that nitrogen makes up 70% or something, 78, I think, of our air. But you don't want it to make up the 100% of our air, because then you don't have oxygen, and that is not great. And so that is one of the benefits, for example, of blowing these things with that upwards vent, and that's what the box fan vent is about.
By the way, you know what else is exciting? We are now under 1 hour to go until launch of Starship Flight 12. So far, SpaceX continuing to proceed with the countdown. At this point, we are now under an hour to go. The excitement is getting real. I mean, I'm starting to feel the hype. I don't know about you guys. Alex, you feeling the hype?
I am. We're really close now. We are just under 1 hour to go. It is one of those things where it's like we have not heard anything from SpaceX yet, so it does seem like we may be closer now to that start of the go no go pull sequence, which should hopefully be in now under 9 minutes.
Oh man, that is so cool. Under 9 minutes potentially from that. I'm guessing you're excited here too, Ryan. Also, I saw Scott Manley in chat pointing out, which by the way, hello, Scott.
Hello.
pointing out that Scott's seeing Jared Isaacson's plane apparently inbound. So hopefully.
I don't know if they would say this publicly, but I wonder if they've waited for the special guest to arrive. I don't know. I do see. Yep, I see that now. I see an F5 on its way over the Gulf of Mexico, inbound from the northeast. So I will.